right, guys. So, what is the order of the matrix and how can you tell? So, the order is that you're going to 2 by 4. 2 by 4. So, rows and then columns. So, your rows first, then columns. So, how many rows and then columns? What is the order of the matrix? 2 by 2. Then rows, then columns. What is the order of the matrix? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. 5 by 2. Rows, then columns. Why can't these be multiplied? All right, so this is a 1 by 2. 1 row, 2 columns. This is a 1 by 2. This number and this number have to match to be able to multiply them. So the columns in first matrix have to match the number of rows in the second matrix. So columns in first, rows in second. That number has to match. Otherwise, they cannot be multiplied together. All right, so working on this guy. Why can you multiply A times B but not B times A? So A is a 2 by 2, and this is a 2 by 1. So A times B would be 2 by 2 times 2 by 1. The 2 and the 2 match, so you can rock and roll, and you'll end up with an answer that's a 2 by 1. The final matrix when you do A by B would be 2 by 1. Now, B times A would be 2 by 1 times a 2 by 2. Sorry, I'm struggling. These guys don't match, so they can't work inversely, so it can't work backwards. All right, can these multiply? How can you tell? Again, 2 by 3, 3 by 3. So these threes match. So you're rocking and rolling. And when you're done, you should have 2 rows and 3 columns. Oh, and that's a 2 by 2. I'm sorry. 2 columns. 1, 2. So you should have only 2. It should be like 4. 2 by 2 when you multiply this guy out. Can these multiply? 2 by 3. 2 by 3. These numbers do not match. So no, they cannot. How do you know if these matrices can be multiplied? So 3 by 3, 3 by 3. These do match, and your answer is going to be a 3 by 3 matrix as well because of these outer numbers. So when you're done multiplying this, you'll end up with 3 columns and 3 rows. Use A and B, find the solution. Are the matrices equal? Do the dimensions add up? I'm not exactly sure what we're asking here, but we're going to multiply it, I think. So we have a 2 by 2, so you want to check it. 2 by 2, that's the first one, times a 2 by 1. So those guys in the middle do match. And then we should end up with a 2 by 1. So it should be 1 column, 2 rows due to these numbers on the outside when we're done. So we're going to take the first one and multiply it down. Top by the top. First one by the first one. If you're looking like first in the row by first in the column, multiply that. And then we're going to add it to the second one multiplied by the bottom number. So 6 times a negative 7 plus I. And I just put the 6 in the front because we typically like to look at distribution that way. So 2 times 5 is 10. 2 times a negative 4I is a negative 8I plus 6 times 7 is a negative 42. And then 6 times I is 6I. Now we're going to combine like terms. So we have an 8I and a 6I. That 8's negative, so we're going to have a negative 2I. And then 10 and negative 42 are going to give me 32. So that's the first column. So at the top, 32 minus 2I. Then you're going to do the same thing at the bottom. First number, top number. So 3 minus 4I. Whoops, sorry. Times 5 minus 4I as well. Now, you can box, foil, however you want to do this. I'm going to foil. So 3 times 5 is going to give me 15. 3 times a negative 4I is going to give me a negative 12I. Negative 4I times 5 is a negative 20I. Negative 4I times a negative 4I is going to give you a positive 16I squared. positive 16i squared, but that I squared is going to be a negative 1. So 16 times a negative 1, so it should be a negative 16. So we have positive 15, negative 12i, minus 20i, minus 16. And again, that's because every time you see an I squared, that is negative 1. Combine our like terms, so our 15 and our negative 16 are going to leave me with a negative 1. Negative 12i and negative 20i give us a negative 32i. So negative 1 minus 32i. And that should be your answer for that guy as well. All right, find the product of the following two matrices. Remember, rows times columns. Yep, rows times columns. So we're going to multiply it. The 2 by 2 means we're going to end up with a 2 by 2 as well. So these two match. That means we can multiply. This one and this one tells us what our answer matrices is going to be. 2 by 2. So we're going to take the top row, multiply it by the first one. So 5 times 10 plus 6 times 4, which is 50 plus 24, which gives me 74. So that's going to be in the first column, first row and first column. So we're going to put a 74. Then we're going to do the same thing to the second column. So 5 times 7 plus 6 times 31. 5 times 7 is going to give me 35. Plus, I believe it's 186. Let me double check it. Ooh. Yep, 186. I'm going to add those together and get 221. So that's the first row, second column. Then we're going to do it again, but we're going to do it with the bottom row. So we're going to go to the first column. So 2 times 10 plus 23 times 4. So that's 20 plus 92, which is going to give us 112. And that's the second row, first column. So second row, first column. So 112. Then we got to do it to the second column. So 2 times 7 plus 23 times 31. So that's going to be 14 plus 713. Then I add that to that 14 and get 727. And so then this is the answer when you have the product. So multiply, because remember, product means multiply. All right, what is the answer for the multiplication of row 1 and matrices A by row 2? So we're going to take the first number times the first number. So negative 3 times 1. Second number times the second number. And add that to it. 7 times 4, which is a negative 3 plus 28, which 25. Yep. So 25 is the answer to the question that was asked here. Now, this is a 2 by 2. This is a 2 by 2. This means we can multiply it. And these two numbers let us know that when we're done, we're going to have a 2 by 2 matrix here for your answer. All right, matrix of minors is not going to be on your quiz, so don't panic. Is it possible to multiply these matrices? If so, what is the product? Okay, so I think this shifted when I made it into a PowerPoint again, so I think this is B. This is a 2 by 3. This is a 3 by 2. So these numbers do match, and your answer is going to be a 2 by 2 matrix when we're done. Let's see if I can write on top of that and save some space. Disregard this B. All right, so we're going to take, this is a lot of math. We're going to take our top row and multiply it by, we'll go first column first. So 3 times negative 2. Whoops. Negative 6 times 6. 9 times negative 1. So that's going to give me a negative 6 plus a negative 36 plus a negative 9. Which gives us 51. It's going to be a negative 51. So first, negative 51. Then you're going to the second one. So 3 times 10 plus negative 6 times 5 plus 9 times 8. That's 30, negative 30 plus 72. These guys cancel each other out. Whoops, I didn't make a number. 72. So it's the top row, second column. So it's going to go in the top row, second column. Then you're going to do the same thing with the guys on the bottom times our first one. So negative 7 times a negative 2 plus 4 times 6 plus 1 times a negative 1. That's going to give me 14 plus 24 plus a negative 1, which is going to give us 37. And again, second row, first column. So that's where it's going to go, second row, first column. Then we're going to do it for our second column. So negative 7 times 10, because first and first. And then we're going to add that to 4 times 5. So second times second. And then we're going to do 1 times 8. So last times last. So it's going to give you negative 70 plus 20 plus 8. So that's 70, 28. It's going to go... Answer should be 42. And it's going to be a negative 42 because that 70 was bigger number and it's negative. So again, second row. I'm sorry. Yep, second row. Second column. Second row. Second column. So it's going to go here. And then that's your answer when you multiply those two together. I'm going to stop this video to make sure there's not too many. All right, guys. Check you on the next one.